Leetcode 3170. You are given a string S. It may contain any amount of star characters. Your task is to remove all the star characters. While there are star characters still left in the string, you should do the following operation. Delete the leftmost and the smallest non-star character to its left. So delete the leftmost star character, as well as the smallest non-star character to its left. Smallest, I'm guessing, just means A is smallest, B is second smallest, etc. If there are several smallest characters, you can delete any of them. So if there are several A characters to the left of the star, then it doesn't really matter which one you can delete, which one you will delete. And then after that, return the lexicographically smallest resulting string after removing all the star characters. Lexicographically means just A is less than B. Okay. Now, what I like to do to start off with Leetcode problems in my little experience is go through the example problems and then see how you would do it without code, and then try to convert your process into code. So AABA star. Let's actually go through this problem on the whiteboard. Okay. So example 1. What is it? AABA star. Okay. So I'm guessing we're going to have a loop that iterates through the string for each character. Delete the leftmost star. So first you really just want to you want to go from the left of the string to the right of the string, and you want to find the earliest star that occurs in the string. So in this case, AABA star, we would iterate through the string, we would find the leftmost star, the only star in the string, and then once we find that star, we delete that star, as well as the smallest non-star character to its left. So once we find this star, we're going to delete it, so the resulting string would be AABA, and along with that you have to delete the smallest character to the star's left, which would just be this A, which would make the resulting string be AAB, which I believe, yes, that is the output in the example, and this is the result. Example 2. Let me just switch screens so you guys can see this. Example 2 is ABC, and obviously there's no star in ABC, so you just return ABC. And I think that's an edge case where you can handle at the start just to save time. There's no star on the string, yeah. So I believe I think it's I think the contain function does this work? Let me see, because this is a test case, right? So I want to see print s dot contains star and see if that works. String has no object. Then let's try star in s. I'll put null. That should return true. Oh yeah, it does. It returns true here and false here, which is what I want. Okay, so the and operator is what we want to use. So I think our edge case is if star is in s, or if star is not in s, then we can just return s. Sorry, Java. And I think that should work for the second case. Okay, cool. So that's our edge case. Okay, so we only get 2 example problems, so I think I need to make my own examples where there's multiple stars, because that's obviously where this problem gets a little tricky. So I'm actually going to make my own example where s equals, let's just put some random letters like B, C, D, star, E, F, G, star, and then Z, Y, X, star. And let's go through what happens in this string for the problem. So we go, I think our outermost loop is going to be a while loop that runs until there are no stars left in the string. So obviously first step in this problem is to find the leftmost star. This would be here, so we would iterate through the string. Once we find the star, we stop, and then we delete this star, which turns into B, C, D, E, F, G. Actually, let's go through both of the steps in the same one so we can save space. B, C, D, star, we delete this star, and we delete the smallest non-star character to its left. So now we're looking at this, and we find the smallest character out of these is B, and then we delete this. So we delete this and this. So the resulting would be C, D, E, F, G, star, Z, Y, X, star. And then we do the same process over again. We look at this, we find the leftmost star, which is this. And then we look at all of these, right? And we find the smallest character to the left is C. So we delete this and this. D, E, F, G, Z, Y, X, and then star. We do the same process. We see the star, and then the smallest character would be D. So the result of this string, or this solution, is E, F, G, Z, Y, X. That is the result. And now really all we have to do, unless I'm missing something, is put this thought process into code, which doesn't seem that difficult, but maybe I'll regret that phrase. Anyways, so we want to do a while loop while there are still stars in the string. Maybe we should comment first what we want to do to make it easier to read. So I think this is easy to understand, but just in case. While there are... Oh, shoot. Yeah, you guys cannot see that, but yeah. While there are still stars in the string, the first thing we want to do is find the leftmost star. Or if we're iterating from left to right through the string, we just want to find the first occurrence of a star. The highest occurrence of a star. Once we find the first occurrence of the star, I think what we want to do is, when we find the first occurrence of the star, we want to keep track of, put the index of the star in a variable, and then iterate from the start of the string to the index to the left. So say we have the string AABA, like the problem, like the example problem 1. We find the first occurrence of the star, which is the last character in the string, and then we iterate from the start of the string to the character to the left of the star. And then out of those characters in that frame, we want to find the lowest, the smallest non-star character. So find the first occurrence of the star. We want to iterate through the entire string. So, but we want to keep track of the index. So for I in range, do we want to make a variable? For I in range length of s, so we're iterating through the string, right? We find a star character. So if si equals star, or is it char at? If s dot char at I equals a star, then we want to we should probably have a variable up here keeping track of the index. Star index equals -1, meaning we haven't found a star. Then we want to update the star index to equals I, right? And then once we find that star, so we found the index of the star, of the leftmost star. Now we want to iterate I in range 0, the start of the string, to I believe this is exclusive, so it would just be star index. So I believe this is going to iterate from here to here. Ah, that's the catch. We have to return the smallest string after removing all the characters. So what I think is we actually want to iterate from star index to 0. Star index to 0, and I believe this makes it iterate backwards. So now we're actually going to start from here and then go here. Because if we go from the start of the string to the end of the string, it wouldn't be lexicographically smallest because the start has precedence over the end. So I think you want to iterate from the end to the start. Let's try it. And then okay, this is the tricky part. So we have to keep track of what is the smallest character in the string. And once we find the smallest character, okay, so what I think that's not. So we want to iterate from right to left. No, but it really doesn't even matter at the start. We just want to keep track of what is. Iterate in the window, keeping track of the smallest string, or the smallest character in window. So I actually kind of just want to test something first. I want to test print A. Oh my god, sorry for my typing. A is less than B. This should return true. String has no character. Can we do this? It's probably because I don't have any return. Oh, it's because of the while loop. Yeah, I probably should just have a break. So true, if this should return false. Okay. So this should work. So we iterate from left to right. Star index. We iterate from left to right. And we want to have a variable called smallest char equals A. Keeping track of the smallest character in the window. So we iterate from the start to here, and then we keep track. So it should be A. The result of this should be A. Can you do a min? Hold up. I think I have the, I want to print the min of A and B. Can I do that? The result is A. I can do that. Okay. That helps a lot, actually. So for I in range, so we iterate through the window. Smallest character should be, actually, let's initialize the variable after we find starting index. Smallest character equals min smallest character and character at I. That should work. So the result of this should be A. Start index is not defined. Oh. Oh. Oh my god, I'm stupid. It is star index, not start. Output is null, but okay. Yeah. Out. Yes. That's what I wanted. Smallest character. Now we found the smallest in the window. Now delete the care going right to left in the window. So say in the example 1 problem, this is our window. Our iteration here finds that the smallest character is A, and that's all it does. And then our second iteration, when we go from right to left in the window, I want to delete the first A that I find going from right to left. So it would just be this rightmost A. And then that would leave us with the result being A, A, B, like we have in the problem. And I'm probably missing something, but that is what we're going off right now. So now we want to iterate from right to left. So for I in range, star index, but I believe the first one is inclusive. I believe the start is inclusive. The stop is exclusive. Yeah. Start inclusive, stop exclusive. So we actually want to do it -1 exclusive. And I believe it's -1. Since this is exclusive, it should just be 0. I think that's right. So we're iterating from right to left. And then if s of I, if the character we run into equals the smallest char. Then we want to I believe it's just delete, replace. Okay. Then s dot replace the smallest char with just empty. That should work. But we also have to get rid of the star as well. Can we do that up top? I think we can because we're... No, but then if we delete that, the indexing is going to be all wrong. So I think after this, we're going to do s at star index. Can we just do equals... Can we just do that? And then return. This is definitely not going to be right first try, but return s. Does not support item assignment. Okay, what if we delete it up here and then just deal with the indexing shit? So I think we have to go to the whiteboard. So right now, when we're going through the string and we find the first occurrence of a star, we're not deleting it at first, and we're just iterating through the window, seeing what the smallest character in the window is, and we're not doing anything with the star right now. My question is, if we delete the star at first, right, so it's here, then our window would be from 0 to star index is 0, 1, 2, 3. So our window would be, I think our window would be the same. It would be from 0 to 3, where 3 is exclusive. And that would be where the star index is, which I think we're already doing. So I don't think removing the star at first is going to harm anything. So let's see. How do we delete it? Dot replace. That doesn't help. Is it really only the replace? It has to be something else. Oh, the replace takes in a index. Wait, no it doesn't. How many occurrences of the old value? One of 3 2 occurrences, so it'd be 3 3. Yeah, it goes from left to right. That's it's probably extremely easy, but I'm just missing it. And this is probably wrong too, because it probably just removes the first occurrence. How to remove a character at a specific index. You create a new string. Strings are immutable, that's why. That's a pain in the ass, isn't it? Okay, my question is, do we at first convert the string to an array so it makes it easier? So equals list s print result. Okay, it works. Length of the result. If result I equals that, then how to delete element from this Python. Is this just remove, dot remove? Remove I. First occurrence. Using index. Oh, you can pop. Okay. Result.pop star index. Result I star index. Result I equals smallest character. Result.remove. I believe it's just, wait. Smallest character. Result.remove. Oh no, it's .pop. And then we don't need this. Let's just see how this works. End result. And then we want to turn result.join. Let's just see what this does. Thought that worked. List to string Python. Oh, you have to, okay. That dot join. Dot join result. Just see what this does. We got B. Oh, did it remove all? Oh, do we want to break after? Then break. Break. We want to break once we find both of these. No way this is it, though. I must be missing something. Oh yeah, you know when it's taken a while, I definitely missed something. What did I miss, Leetcode? Oh shit. Interesting. D star. I returned D, but obviously... Okay, back to the whiteboard, see what we missed. So... S equals D star, right? So let's look at the code, see what we're doing. So we make S result equals D and then star. That's what we're doing first. Then star index equals -1, while star is in result, which it is. We're iterating through the length of, we're iterating through result. If the character we find while we're iterating through result is the star, we make the star index I. So we iterate through result. If star index equals I, we put that into a variable. So star index equals 1. Star index equals 1. Then we pop. Then we just delete the character, the star. So now result equals, now everything that's left is D. Oh, it might be because we're iterating like that. I don't think it is though. Okay, we're breaking out of it now. Next one, smallest character equals A. We're iterating from the window. So from 0 to 1, but 1 is exclusive, so it's just the starting character. That's the smallest character. We set smallest character to... Oh! No! That's why. Obviously this is wrong, because we're setting smallest character to A, when we really should be setting it to, like, capital Z. Because it's just going to get overridden by this. When we set it to A, the result is always going to be A. So that's obviously what we don't want to have. Let's see if that helps any. Probably not, but obviously that was a mistake. Interesting. Doesn't even pass that. Now we're not deleting anything. Okay, what is going on? Mouse character and result I. Let's print out what we have as a smallest character. So obviously our smallest character is Z? What if we do smallest character as lowercase c? Oh, is capital Z before lowercase? Capitals are before lowercase? Interesting. Oh, yeah, probably should remove Okay, so we passed most of the test cases. Maybe if we get rid of that, it'll be faster. So the problem's it's too slow. That's a really long case. So it's requiring a very efficient solution, which we probably don't have because we're iterating through multiple times. Huh. For I in range. Obviously for small, is there just a way to make this faster? That's stupid though, because it works, it's just not that fast. maybe we keep it. But the problem for me right now is if we keep it at a string, strings are immutable, which I don't think works great for this problem. It's just too slow. Like, it works. It's just way too slow. I really want to get through this without help. But obviously I have to probably just like redo what I'm thinking if I want to make this fast enough to pass. If result I equals and this is just because I don't know what really heaps are. Okay, this works. I don't know. This Boolean array will keep track of the characters from the original string that have been deleted, the size of length s. No while loops. That's actually kind of smart. You don't have a while loop, you just have a Boolean array which keeps track of which characters have been deleted so far. enumerate Python. So right now, I know it seems like I have cheated on this problem, which partly I have, but with my limited knowledge, I definitely would not have found this solution out. I mean, I had a correct solution, it just was not fast enough to compute strings where it just takes up a full page. It said it like accepted 533 out of like 600 test cases, and those last like 70 test cases were probably just full-length pages, which my solution was not fast enough to run on. But sure, I may have cheated, but for these first couple of solutions, or for these first, I just really have to get down learning data structures. And once I learn these tricks in solving these problems, I think I'll be able to get more problems down without like checking for a solution. But I think that was a good attempt. I may have been able to do it on my own if I did some research, but this like deleted, this is just a little too advanced for me at the moment. But hopefully, as I keep working on these problems, I'll pick up these tricks and these things that are reoccurring. I've seen this before, where you have a Boolean array to keep track of things, but that just didn't pop into my mind at first. And if I sat here for like a full day, I probably would not have found the solution. But hopefully, after a couple months, I'll be able to solve this problem without cheating per se. So right now, I'm just going to try to learn the solution and what it does. So first thing, enumerate. I've run into this. I just need to like sort of recall what it is. It adds a counter to an iterable and returns the enumerate index fruit and enumerate fruits. Okay, so it returns the index and the element. The index and the element. Okay. You obviously keep it in the string formatting, even though it's... What do you return? Result characters? That's an array. Yeah, you need an array because strings in Python are immutable, which means you can't append characters to it, you can't delete characters to it. You can replace, but that doesn't really work in this problem. So you iterate through the string. If you run into a star and the min heap array is not empty, oh, so if the star is found, you do this, else you heap q.heap push. Binary trees where each parent node's value is less than or equal to its children for a min heap. Oh, need water. Yeah, I'm not very familiar with heaps in general, but this is why I'm here, to learn these algorithms, to learn these data structures. Heap q.heap push. For a regular counter is encountered. Add it to the heap for potential future deletion if a star appears later. Store care. To correctly handle tie-breaking rule. Negative index. Smallest element is always at the root of the heap. So it's a binary tree. So it basically sorts it? But you're storing negative the index, meaning the first element in the heap will be this, the largest index, meaning this A is going to be before these A's, because a higher negative value is obviously more negative, which means it's smaller. So that's a clever trick, actually. I think all these comments are, I mean, they're kind of just like annoying. No, that's the wrong use of words. They're just like, I feel like I'd understand it better if I just read the raw code. Because there's really not that much code. See, this looks a lot more manageable. Okay. So we're gonna push this. I actually want to print. I just want to see. So you can do this. And as you can see, the most negative goes first, meaning basically this A comes before these A's, meaning it gets priority for deletion. Which is good because that follows the lexicographically smallest resulting string. It's very clever, and you probably need a good understanding of heaps in general, which I have very, very little experience with heaps. But I think I get it now, at least this part. So really, you're just like reversing the string. for deletion priority, which is pretty clever. And you're doing this in a time efficient manner, which you need obviously. Okay, you do all this until you reach the star character. Once you reach the star character, if there are elements inside of the heap, you're going to... What is this? Okay, interesting. So when you pop an element from the heap, it's going to give you two values. Obviously, because when you pop, you're going to pop this tuple, and the two values are going to be the element and the index. So you're going to store these values in this undercase, lowercase thing, whatever, you get what I'm saying. This, you don't need this, which is why it's this character. You only need the index. So this is original negative index. Oh my god. Okay, that's clever. If heaps actually are ordered in such a way that... I don't think it is. But if it's ordered in such a way that smallest characters go before largest characters, but I think that would make it so this would proceed over this. So I don't think that's true. Okay. So original index, you're getting back the regular index. And then you're going to delete that index and put deleted as true. Heap pop min heap. If min heap q dot heap pop. Then result characters. If the character is not... That is smart. You're going through if the character has not been deleted from up here, and if it's not a star, because obviously you want no stars in your resulting answer, you're going to append that, and then you're going to just return that. Very smart. So really, this problem just makes you use your knowledge of heaps, which that was probably the intention behind this problem. Always provide the smallest element. Interesting. It's just time efficient. This is what I did. I wonder if doing this will... Is that faster? 687 before, 637 after. Yeah, that little change did add some stacks. This one uses heaps as well. Interesting. Well, I think that's it for me. After this, I probably will grind and learn some more about heaps, but from now, that's all I got. Thanks for tuning in, guys. Peace.